morning. Happy Tuesday. Today we are going to work on surface area of prisms. These are 6 examples of prisms. You have your triangular prism, your square prism, rectangular prism, pentagonal prism, hexagonal, octagonal. It can continue. The only ones that we are going to deal with are going to be these 3. You may see these later on in high school at a much more advanced level, but we will not be focusing on those. And one of the things that we know about prisms is that they are 2 base figures, meaning they have 2 bases. You would see a base here, so this would be the other base. This could be the base, and then you'd see the base. And those bases, we sort of pick those out because they're going to be parallel. You would have that as your 2 bases. And if we look at those faces, we see, actually it goes like that, we see that they are parallel to each other. If we put our hands on them, it would come out as parallel. They would be parallel to each other. So very important that that's how we find out which ones are the bases. The 2 bases will be the parallel. They will be parallel. We see that this side of the triangular prism and this, sorry, that's not very good. That back side would not be parallel. It would make like a teepee. So it would be this part of it, and this part would not be parallel to each other. So the only 2 sides that are parallel in a triangular prism would be the front face and the back face. If we look at a square prism, and this is where it gets very interesting, and perspective will be important, we could definitely look at this as the 2 parallel bases, because if we put our hands on those, they would be parallel to each other. But what is interesting is we could also call these as the bases, because those are also parallel. So you have multiple sets of faces of this object that are parallel. So we could call these the bases because those are parallel. And then the other set would be the tops. The top and the bottom would also be considered, could be considered bases. If those are the bases, then this would be the height of them, the distance between them. Whoa. If we, come on. No, not going to work. Stubborn. If we look at the front and the back as the bases, then this would be the distance, or the height, the distance between it. The height's always going to be the distance between the 2 bases. If we did the top, maybe we didn't do the top. Did we do the top? And if we did the top and the bottom, then the height would be what our traditional. It's the distance between the 2 bases. And if we did the left and the right, the height would be the distance between it. So it'll be very important for you to figure out, to choose in your square prisms and your rectangular prisms. You may have a difference of opinion on what you call the bases. So if I call the front and the back the bases, okay, that's fine. And then the height would be the distance between those. So we may have some differences in what we consider the bases with the square and rectangular prisms. And then the triangular prism, everybody will have the same. So let's take a peek at one of these. First of all, the first thing that we want to do is we want to look at the object. And we sort of, you don't have to, but you can open it up into a net. A net breaks it into a 2-dimensional. It takes a 3-dimensional figure and breaks it into a 2-dimensional figure. So you notice what we talk about when we're finding the surface area. We have something called the lateral area and the base area. So the lateral area is sort of like the waist. it's the waist around it. Waist meaning a body part. So that would be this part. It would go around the object. So if we had the waist, this would be the waist of it, yes? And then the top and the bottom would be the bases. So in this example, we're finding the top and the bottom would be the bases. So that would be the base, which is a rectangle, 45 by 36, and then the bottom would be it. And then if we took this, we took the waist, the lateral area, and opened it up, we would get this rectangle, this long rectangle. And so the lateral area ends up being a rectangle. And here is our rectangle. And whenever we find the area of that, so we need to find the area of the bases, and we would have to find the area of the lateral. And if we have this this rectangle, rectangles have the formation, the area of base times height, the base times the height, we notice that the lateral area is actually what we call the perimeter. It's the distance around an object. So we would call this distance the perimeter. And we would add up each of the sides, 36, 45, 36, and then another 45 over here. So we would use that as my base. So that perimeter will also be seen as the base of the object. And then we would find the base, which would also be base times height of each of these bases, the top and the bottom. So let's take a peek. So we have this figure. We have our formula is surface area equals lateral area plus 2 big B. We'll call it just big B. And that's because we have two bases, a two-base figure, so we have 2 big B. Big B stands for the base area, which is here. Lateral area plus 2 times the base area, because we have a top and a bottom. Like 2 bases, and then the lateral area. So the lateral area is a rectangle, and that rectangle is the perimeter. The base would be considered the perimeter. So the perimeter is going to be the distance around the object. So we have 36 plus 45 plus 36 plus 45. And we're going to multiply it by the height. Remember, the height is going to be the distance between the bases, between the top and the bottom, and that's going to be 54 inches. So that is just for the lateral area. So if we add that up, let's get a calculator over here. We have, let's clear it, 36 plus 45 plus 36 plus 45 gives us 162 inches, because each of those is inches, and inches plus inches doesn't give us squared, it just stays, because we're adding, it stays in inches. And we're going to multiply that by 45 inches times 45. I just did 54 because it says 54, not 45. Sorry, a little dyslexia right there. So 162 times 54 gives us 8,748 inches squared. Now it's inches squared because we're multiplying inches times inches. So that would be just the area of this waist, the waist around, meaning around your body. And now we have to find the 2b, and that shouldn't be s squared, that should be bh. Sorry about that, because it's going to be a rectangle. Formula for rectangle is base times height. So we have 2 rectangles, and that's going to be our bases here. So we're talking about this area and this area, and they're going to be identical. So that's a rectangle, as we see, and we have base times height. So the base would be 36 inches times 45 inches, which is the height. So if we saw this, it's 36 inches by 45 inches. So 36 times 45 gives me 1,620 inches squared. And remember, we have two of these, so we're going to have to multiply that by 2. And we get 3,240 inches squared. So this value would be our lateral area, and this value would be 2 times big B. Big B always represents the base area. And let's add those two together, 8,748, and we get 11,988 inches squared. The surface area of this object, meaning the skin of the object, big difference between volume. Volume is inside, surface area is outside. It's like your skin. It's like the orange peel. It's like the cereal box. If you had the cereal box and you took the cereal out, that would be the surface area, would be the box that contains all the cereal. I like that example. All right, so that would be surface area of a rectangular prism. So what I'd like you to do is you try this one, pause it. You see that you have some congruency signs here. You see you have some congruency signs. That means that each of those sides, this is actually a square prism in this example. So pause the video, try to find it, and then unpause it, and we'll go through your answer. Okay, so in this example, we have two squares, and as their bases, this is what I'm going to call the base, and I'm going to call this the base also. So those are my two bases. So my surface area, my lateral area will be this component of it. So my lateral area, if I opened it up into a net, it would be 12 meters plus 12 meters plus 12 meters plus 12 meters. That's the perimeter around this object. And then the height of it would be 16 millimeters. So I have 12 millimeters plus 12 millimeters, which gives me 48 millimeters would be the perimeter. And that's where we are here. So that's the perimeter times the height. So I have 48 millimeters times 16 millimeters, which would be the height of the object. And 48 millimeters times 16 millimeters gives me 768 millimeters squared. Now let's go back to my two bases. So I know that the base shape is a square. So my base area is going to be s squared. So I have my side, which is 12 millimeters. 12 millimeters squared would give me 144 millimeters squared. And I have two of those bases. So 144 times 2 would give me 288 millimeters squared. And then I would add that to the lateral area, 768, and I get 1,056 millimeters squared as my surface area. All right, now let's try a triangular prism. So the first thing I need to do is find the bases. Remember, the bases are going to be the two faces that are parallel to each other. In this example, it's going to be a triangular triangle. So those triangles are parallel to each other. So those are going to be my two bases. My base shape is a triangle. And then my lateral area is going to be 3 sides this time. So going around this triangle, I would have something like 8 centimeters, 6 centimeters, and then 10 centimeters. These technically are the sides of the triangle if I opened it up. And then the height, remember, is always going to be the distance between the two bases. So my height is going to be 15 centimeters. So I'm going to, again, this lateral area ends up producing a rectangle, and a rectangle has the formula base times height. This base ends up being the perimeter, so I'm going to take 8 centimeters plus 6 centimeters plus 10 centimeters, and that gives me 24 centimeters, and then I'm going to multiply it by its height, which was 15 centimeters. So in the handy dandy calculator, I'm going to take 24 and I'm going to multiply it by 15, and I get 360 centimeters squared because I'm multiplying centimeters times centimeters. That would be the lateral area. Now let's figure out the base area, the 2B, 2 big B. So first of all, here's my base. My shape is a triangle. A triangle has the formula base times height divided by 2. So I'm going to take the base of the triangle. The base would be 8 centimeters. And I'm going to multiply it by the height, which is 6 centimeters. 6 times 8 is 48 centimeters squared, and then I have to divide it by 2. So half of that would give me 24 centimeters squared. And that's just for one. That's the area of that base. And since I have 2 of them, I have a top and a bottom, or a front and a back in this case. We call it front and back, top and bottom. So I'm going to have 2 times 24 centimeters squared, and this is my 2 big B, my 2 times the base area. So 360 centimeters squared plus 2 times 24 gives me 48 centimeters squared, which gives me a total of 408 centimeters squared would be my surface area. That's the outside skin of the object. So of that triangular prism, that would give me my surface area of that. So here is, we just did that one. So here's an opportunity for you to try. Take a moment. Using the formula, be systematic. I would definitely be writing things and trying to keep track of them using the formula SA equals LA plus 2 big B, and then fill in the components. So pause the video. When you're done, unpause it, and let's go over the answer. All right, so my lateral area is a rectangle. And remember, the perimeter is going to be the distance around that triangle. So we have 4 inches, 3 inches, and 5 inches. So 3 inches plus 4 inches plus 5 inches gives me 12 inches. And then I'm going to multiply that by my height. That's the distance between the two bases. So in this case, my height of my lateral area is going to be 7 inches. 12 inches times 7 inches gives me 84 inches squared. And now we're going to work on my bases. My base shape is a triangle with a base of 4 and the height of, and when I say a base of 4, now we talk about the little b. So when we see big B, we're talking about base area. When we see little b, we're talking about the base of the object. So our object is a triangle. The base is going to be 4 inches. My height is going to be 3 inches. So we have 3 times 4, which is 12 inches squared, divided by 2 would give me 6 inches squared times 2 would go back. We could also see that that 2 in the numerator and the 2 in the denominator will cancel. So we could save some time about when we have these triangles dividing by 2 and then multiplying by 2. So we have 84 inches squared plus 12 inches squared gives us 96 inches squared. If you have questions, it's probably something that you might have a couple questions. I hope to see you in office hours with specifics. This is definitely something that you might want to go find objects. If you have a Toblerone chocolate box, if you have a Cheerios box, helping you with surface area is going to be very important. I will also be linking 2 other videos from YouTube that have people who have more tangible and you can see them work the object in front of you so you can use your eyes. This is a little bit challenging with no 3-dimensional objects for you to see. Thanks. Good luck. I'll talk to you tomorrow.